Woohoo! Welcome back. Today we're going to be talking about the area between curves. And in order to get help with this, I have invited our friend, Lowly Worm, who knows all about curves, to come and help us. So, here we go. You guys ready? The question is, if the integral, this is a definite integral, between a and b of f of x dx gives us the area under f of x, how can we find the area between two functions? So I'm going to move Lowly Worm over a little bit, just like that. And I'm going to bring in a helpful visual aid. So if, look at that, I know, no expense spared for this. If this right here, this pink curve is the curve y equals f of x, then the area under this curve is what's shaded in blue. This is the integral, the definite integral from a to b of f of x dx. And that gives us the whole area of the blue. But we don't just have f of x. We also have g of x. G of x is this light blue, kind of hard to see curve right there. It's this little guy right there. And this, the integral from a to b of g of x dx, gives us this white region right here, that area. And so what I'm going to suggest is if we take the area under f and we subtract out the area under g, what's left is the area between the two curves. What do you guys think? So how do we take something out? How do we remove something? Well, that's just subtraction. So it turns out that it's very straightforward. All you need to do is subtract f of x minus g of x in that same definite integral. And you got it, which is really cool. And then I go on to write, however, it might be surprising to discover that this is also true as long as f is greater than or equal to g for all values. So they can't crisscross. So you're not allowed to have f do something like this. Can you guys see that? Kind of, let me scooch it up. And g do something like this. They can't switch places. This is not allowed. So as long as f is greater than g at all points, it actually doesn't matter if f and g are both positive, which gets really interesting. And so I asked at the bottom of this page, why is that true? It's a fair question. Why is it true that it doesn't matter as long as f stays greater than g? G is negative over here. So when we talk about subtracting, we actually, let's see, the area under f is going to be this, right? So it's all of this, including the white part that we don't want to include. So that is the integral from a to b of f of x dx is this shape. Let me see if I can kind of approximate it here. It's the shape that looks like that. Oops, scooch. So why does subtracting g still work? Because over here, we don't want to subtract it. We actually want to add it. But then over here, we do want to subtract it. And notice that over here in this region, I'm going to use the opposite direction, g of x is less than 0, which means it's negative. Okay, so how does that help us? what happens if you subtract a negative? So let's say right here, g of x is, for example, -3. Let's just say. So then what happens if I do f minus g? That would give us f minus a -3. Well, what's f minus a -3? Sorry about that. F plus 3. So we end up adding. So it still works. When g is positive, if we subtract that part of it, we take the whole thing minus this little corner, which is perfect. But over here where g is negative, we actually add it. So what we end up getting is that the integral of f minus g from a to b dx is going to be the whole thing, like that. And then we're going to subtract the little piece here. And then we're going to add this little piece underneath. Oh, let's see if I can do it justice. So it's blue. And it has, I drew in the little black hash marks, right? So in subtracting g, we subtract the piece that's above the x-axis, and we actually end up adding the part that's below. So this is really convenient, and we're going to take advantage of this. This is going to be something that we use for the rest of this class, and certainly for the rest of chapter 6. So how do we use this? Well, let me put this pen on this, or let me try putting the cap on the pen, and then let's go ahead and look at an example. What do you think, Lowly Worm? You think that's a good idea? Yeah, I don't remember if he had a voice in the cartoons or not. So he'll just silently agree with everything I say, which is actually awesome, right? So let me scooch this over. The example we're going to work with is to find the area of the region enclosed by the parabolas. Now, how do I know the parabolas? So I'm going to remind you, calculus in its original Latin translates as every little detail and piece of information about math you've ever learned in your whole life. So that's what we're going to be using in this class, everything you've ever learned. So you have to remember back, how do I know it's a parabola? I know something is a parabola when it has the form y equals x squared. Now, can I have extra bits? Yes. There could be numbers running around. Could there be x's? Yes. What's important is that there's no y squared, because then you're into a different shape. So just y and x squared, and then whatever other fancy bits you want. So that's a parabola. So I've got a parabola here, y equals x squared, and y equals 2x minus x squared. Now, what's exciting about this problem? Well, what's really exciting about this problem is that you have to be able to graph it to do this problem, because you've got to be able to see what the intersections are. So first thing I'm going to do is find the points of intersection between the two curves. So as I mentioned, you could graph this, and that's fine. I'm actually going to do this algebraically because it's a little faster. And what I'm going to do is I'm going to say, let's go ahead and find the intersection by, oh, sorry, pterodactyl. Don't pay any attention to me. Find all the points where f equals g. Okay. Now, there's no f and g here, obviously. So I'm just going to set one side, x squared equal to 2x minus x squared. Does that mean this is f? Does that mean this is above? This is the function that's on top, and this is the function that's below? I don't know till I graph them. So I'm just going to set them equal for now, and I'm giving them those names. We can always change f and g later on if we'd like. Or, you know, through the magic of whiteout, we can change it at any point. We just need a little pterodactyl distraction. Pterodactyl. Okay, so I'm going to set x squared equals to 2x minus x squared. Again, calculus means remembering everything you've ever learned. This is now a quadratic equation. You've got x squareds. So now you should be thinking about the quadratic formula. You should be thinking of factoring. You should be thinking of perhaps the AC method of factoring, the zero property. There's a lot of interesting bits to solving quadratic equations. But the big thing to remember is if it's a quadratic equation, and that's something along the lines of y equals x squared or similar, then you want everything on one side equals 0 on the other. So you want to solve everything to the left or the right if it's easier. So if I've got x squared equals 2x minus x squared, I'm going to go ahead. Can you guys see this? You can't quite. Let me scooch it up. Sorry. Don't look at step 2. You don't need step 2 yet. Step 1, I'm going to go ahead and subtract the 2x from both sides. And I'm going to add the x squared on both sides. Now, do you have to do this all in one step? No, of course not. I'm just trying to make good use of the fact that you can't see a lot in this view. So I think I've got over on the left-hand side, can you guys see this? Not quite. Scooch it up a little bit. I've got 2x squared minus 2x, and the whole thing equals 0 because I managed to cancel out everything there. So take a look at that. Then I've got an equation, again, it's quadratic, and I think, okay, you could use the quadratic formula if you'd like. Quadratic formula will never let you down, much like lowly worm, never let you down. However, in this case, factoring is a lot easier and it's going to be faster, so that's how I'm going to do it. If you want to use the quadratic formula, please be my guest. So for this, I'm going to go ahead and say, do I have any common factors? And in fact, I do. I have a 2 and an x. So if I factor out 2x squared becomes x minus 2x. I'm factoring out the whole thing. Remember, when you factor out the whole thing, you leave a 1 and you set it equal to 0. Then there's this wonderful thing called the zero property, which I love so much. It's one of my favorite little bits of logic, which says you can't create nothing. You have to start with nothing to end up with nothing. So nothing doesn't just happen. You have to make it. So here, well, you can't even make it. You have to start with it. Yeah, pterodactyl. It's a lot of pterodactyls. It's my first video back after a long break, so I gotta get back in the video making mode. So the zero property says if I factored the left side and the right side has a 0, then I know that either the first factor or the second factor have to equal 0. Again, I can't create 0. I have to start with 0. So if 2 times x is 0, then I know x is 0. If x minus 1 equals 0, then I know that x equals 1. So the two possibilities are x equals 0 and 1, which is very hopeful. What that means is whatever's going on with our equation, which I'm not showing you the graph yet, but I want to scooch this up so you can see the video, or the graph. So I don't know. They intersect at x equals 0 and at x equals 1. So I don't know what's going on in between, but I know that between 0 and 1, they don't intersect. That's what the zero property tells me. And that I can go ahead and find the area in between them if I integrate from 0 to 1. So that's what I've just learned. That's very exciting. Okay, so let's go on. I know, I'm showing you Dun, dun, dun. I'm showing you the fact that I drew a totally ridiculous graph right here. You can tell. I was just kind of goofing off. But in fact, the two parabolas, along with a piece of whatever that was, look like this. This is, do I have it written in? I do. So I did. Shh. I stole this from someone because it was really great. I stole it from the book. But it isn't written in the most useful way. So this graph is y equals x squared is this guy. Now you can see why they've written y sub b. I would probably actually call this y sub g, but I think they use b for bottom and t for top. I'm just guessing. So x squared, hopefully you know that graph by heart already. 2x minus x squared, hopefully you know that's a parabola that opens downwards since it's a -1 in front of the x squared. If off the top of your head you did not know one went up and one went down like that, I would definitely review graphing parabolas because they're going to come up all over the place in chapter 6 and possibly afterwards. So this is important that you be able to visualize these graphs. Also, I would encourage you that when you're doing your homework, make sure you keep Desmos by your side. Keep checking graphs. Remind yourself how to graph things. Practice graphing things by hand because during tests you won't necessarily have Desmos. But definitely review this. And notice that if I draw the two parabolas, I've got an intersection point where x equals 0. Now, how do I know that y equals 0? Well, when x equals 0, I know that y equals x squared is one of the functions. So y equals 0 squared, that's 0. So that's why this is the point 0, 0. Now, how do I know it's on both graphs? Well, because up here, when I set them equal to each other, I found that there were 2 points where they intersect, 0 and 1. So what happens when x equals 1? Well, again, y equals x squared, which is 1 squared, which is 1. So then we know that that intersection point is 1, 1. Okay. So now what is this box? Well, basically what this box is, hopefully it's trying to remind you of what we studied back in Calculus 1. Or if you're watching this video in Calculus 1, it's what you studied a while back in Calculus 1. And that is that we're going to take a bunch of these rectangles and the width down here, or the base, is delta x. And the height here is going to be f minus g. You guys see that? This is delta x, and this is going to be f minus g. But in this case, the book is calling this y sub t minus y sub b. And you can see why I might call it y sub f minus y sub g, or even just call them f and g. It's up to you. And so what we're going to do is we're going to take the f value, and that goes all the way down to the x-axis. And then we subtract this g value right there. And then we just get the height of this rectangle that sits in between the two functions. What do you guys think? So far, so good? Okay. So then next, I know, you're all like, wow, that's so amazing. We're going to keep going. We are. We're going to keep going. And we're going to keep going. We're going to keep checking to see if I can see this. Can you guys see this? Yes. Okay. Scooch this down. The third step. Oh, sorry, lolly worm. Determine how to calculate the height of a typical rectangle. So, okay, let's bring this back. What the heck? Well, I've got to integrate. And I've got to figure out what these heights of these rectangles are going to be. And so, I know I'm giving it away if you can see down here. Or if you've already printed out the notes, you can also see it. So if we look at the rectangle and we go back to the graph, let me show you again. who's actually the top function in this? The top function is the pink one. That's actually not x squared. That's the 2x minus x squared, interestingly enough. The bottom one is the one that opens upward. That's the x squared. So we're going to have that this height, yt minus yb, pardon me, lowly worm, is going to be 2x minus x squared minus x squared, which is really surprising because this feels like it would be very small or even negative. And so let me remind you again, this is all happening between 0 and 1. And so these are fractions. So when you square a fraction, it gets smaller. And that's why x is actually greater than x squared. That's why this is going to be positive. Okay, so that is that height. But the next question is, what's the actual area of the rectangle? That's going to be the height. I hate the word height, very hard to spell, times the width. Also hard to spell. We've got a lot of words that are hard to spell here. What do you think, lowly worm? Yeah. So then I've got 2x minus 2x squared. And the question is, what was the width? What was this? And again, that is delta x. And then hopefully you remember, through the magic of calculus, we make all the rectangles much smaller and smaller using limits. And then we end up, instead of delta x, with this wonderful little guy called dx. So there's the 2x minus x squared minus x squared. So this is the top function. So yt minus yb, bottom function. And notice that instead of being delta x, like what we had right here, it becomes dx when we actually transition into a definite integral. And so we go from 0 to 1. And then we do the subtraction, which I had already done up here. Now, I do something interesting here. Notice that I factor out a 2. Do you have to do this? No, you do not. So it is completely up to you whether you want to do this or not. I'm actually going to go ahead and keep it that way because I typed it in, but you can skip it. So let me write this whole thing out bigger because I always like to do that. X minus x squared dx. Now the next thing you have to remember, and if it's been a whole break since you last did calculus, you have to remember how to integrate. Oh, that is a terrible integral sign. Sorry about that. You have to remember to integrate. So remember the power rule. You add 1 to the exponent and divide by the results. So there's my 2. My x to the first becomes x squared over 2. And my x squared becomes x cubed over 3. And I'm going to integrate from 0 to 1. So that's going to be 1 over 2 minus 1 over 3, because 1 squared and 1 cubed are 1. And then I've got 0 over 2 minus 0 over 3. Can you guys still see this? Oop, I was slightly off. Sorry about that. So I plug in the 1, and I get 1 squared is 1, 1 cubed is 1. And then this is all 0. So I just get 1/2 minus 1/3, and then we subtract 0. So we don't have to worry about that. Now, what you do now is kind of up to you. Do you want to do this math first, or do you want to multiply by 2? Because there are a couple ways to look at it. Some people are like, ooh, you know what? This is going to fix everything because 2 times 1/2 is 1. So you could do it that way, or you could find the difference between these two and multiply by 2. It's up to you. I'm going to go ahead I'm going to be Cheaty McCheaterson. 2 times 1/2 minus 2 times 1/3. 2 times 1/2 is 1 minus 2/3. What is 1 minus 2/3? You got it. It's 1/3. So I feel like I tricked someone into doing this. Personally, I like this result. But if you'd prefer, notice that right here, if you'd like, and I should probably remind you because it's a good thing to be able to do, 1/2 minus 1/3, you have to find a common denominator, which will be 6. It's 3/6 minus 2/6. If you're not sure why, you should definitely ask a tutor or ask me. Let's go over some fractions. It's never the wrong time to review fractions. Are you on an airplane? Headed for Indonesia? Go over your fractions. Are you sitting on a bus and you're really bored? Go over your fractions. Are you at the dentist? Getting a filling? Go over your fractions. I'm sure the dentist would love that. So if this is 1/6, what's 2 times 1/6? If you think about it, the 2 and the 6 cancel and you get 1/3. So you can do it either way. It's up to you how you do the problem, but that's it. Woohoo. What do you guys think? We're done with our first video, or the beginning of the last video, depending on whether you're seeing this in the Calculus 1 or Calculus 2. Hopefully it made sense. If it didn't, please ask lots of questions. And know that I'm really proud of you. Again, if you're almost done, congratulations, you're in the home stretch. If you're just starting out, good luck. This is going to be a semester where you learn a lot of stuff. It's going to be very cool. But please, please pay attention. If your brain says, I don't know what to do with fractions, give it a little bit of a review. If you're not sure how to graph parabolas, give yourself a little bit of a review. Make sure you've got all the tools you need to be comfortable this semester. Okay, well, that's it. I'm very excited. Let's go party. Everyone should grab something to drink. Remember to hydrate. Go touch a little grass. Try to change where you're focused. If you've been looking at a screen, try to go and spend 20 minutes looking somewhere else at some other distance. Let your eyes rest. Let your body rest. Or dance or sing or go find a friend and talk about how cool calculus is. And I hope you have a great day. And I will see you, quote unquote, in the next video. Math on and woohoo.